Hi everyone, and welcome back to another one of our instructional build videos. On today's build video, we're going to be showing you how to wire up your Sphinx 1050. So this is going to be all inclusive, guys. We're going to show you not only how to wire up your machine, but we're also going to show you how to set up your values and settings in our OpenBuilds machine driver, as well as showing you how to cut out your first hello world. So in addition to that, we have highlight points that we're going to show you right now. Alright, our first awesome addition to this kit is going to be our OpenBuilds LED light ring. And as you can see, it's going to illuminate your whole workspace. Definitely a nice addition to this kit. Another two awesome parts of the kit is going to be our drag chain. So we're going to have not only our X-axis drag chain included in this kit, but also our Y-axis drag chain. And as you can see, we have configured it with our single L brackets, utilizing the OpenBuilds modular system, create this nice sleek look, guys. So in addition to that, we're also going to include our micro limit switches. So this is going to be a full kit. It's going to include all the components you see here. So you're going to be able to run your machine in a homing sequence, which is really nice and convenient. And last but not least, we have our OpenBuilds open case, which is very convenient for the builder. We have this mounted to the back of our machine, and as you can see, it's currently running with our fan circulating cool air onto our controller. Definitely a really nice addition to this kit. So now that we have all the highlights pointed out that are included in your kit, without further ado, let's go ahead and get started. Alright, so for this first step, we're going to locate these parts. We're going to need 4 conductor wire. We're going to need 2 at 3 feet, 1 at 7 foot, and 1 at 13 foot. In addition to that, we're going to need our 4 female connectors and a flathead screwdriver. So in addition to these parts, you're also going to receive 4 male connectors, which we're going to connect to each one of our motors. So as you can see, all of my motors do have the male pins connected. What I've done is just simply cut the excess off, and I've located my coil pairs, and I've aligned them like so. So for motors that have that lead extension, you're going to line up your coil pairs just like so: red, green, blue, and yellow. And you can always test that as well. So if you were to take this connector off, you would see that each set of wire is going to indicate which coil is which in your motor. So for instance, red and green on this motor is a coil pair. So if I connect these two, I'll find resistance in my motor. So by moving the pulley, you'll hear that grind right there. That's the resistance. So also with blue and yellow, you're also going to find that resistance. Now if it wasn't a coil pair, let's say if it was blue and green, no resistance, so it's not a coil pair. So for these motors in particular, guys, it's going to be red, green, blue, and yellow. So we're just simply going to put that back into our male pin. So if you have the new style of motors, which comes with a male connector already assembled onto the motor, your coil pairs are going to differ. So you're going to have red, blue, green, and yellow as your coil pairs. So as you can see, the motors with the leads, which we'll be doing in this video, those coil pairs are red, green, blue, and yellow. So for the new style of motors, we have red, blue, green, and yellow. So that's the difference. If you need to pause the video, go ahead and do so. That way you can see the difference in colors. But basically all you have to do, since these coils are already paired off for your convenience, you take your female connector and you're going to correspond your 4 conductor wire to each one of these colors on your motor. So you're going to have red, blue, green, and yellow. So you're going to be working right to left. And then this will relay to our controller. And from there I'll show you another set of wires attached to the controller. That way there's no confusion. So let's go ahead and continue. So basically with the lead extensions, we're going to be wiring these in particular throughout this video. So if you do have these motors, just follow along. If you have the new style motors, please pay attention to the colored wires and make sure that you wire it corresponding to your motor. Alright, so let's go ahead and continue. And as you can see, for the male connector, I'm working my coil pairs from left to right. So starting with red, then green, then blue, then yellow. Make sure that you align those all the same way if you're following along in this video, because our female connectors have to correspond in the opposite direction. So on the right side of the female connector, you're going to have red, then green, then blue, then yellow. So all of these male pins have been connected. Alright. Alright, so let's go ahead and get started here. For all of our 4-conductor wires, you can see that I've had these pre-stripped. So what I like to do is strip these down with about 5mm lengths. That way they'll fit in the connector nicely, as well as the opposite end. Now this is going to go to our controller board. Same concept though, about 5mm lengths on each wire. So let's go ahead and get started here with our first wire. So this is at 3 feet. What I like to do is twist these wires and make sure that they're uniform. That way we get a solid connection in our connector. Now for these female connectors, along with any of our connectors, they come standard fully tightened. So you'll see this aluminum pin inside the metal connector. You're going to loosen each one of these pins so it'll fully accept the wire. So make sure you do that for all of your female connectors before you try to insert the wire. And remember, we're working right to left for our female connectors, and I'll show you why. Once it connects to the male connector, you want to make sure that red matches with red, green matches with green, blue, yellow. That's exactly how we want to work it, so right to left, guys. Alright, so I'm going to insert red and green. Alright, and then blue and yellow. Make sure you tighten these down completely. Give that a little tug, make sure that they're fully connected. That looks excellent. So we're going to come over here to our y-axis and let's connect that. Alright, perfect. So let's move forward. So same thing for these additional wires, guys. So let's go ahead and get that done. Alright, give that a nice little tug. And this is a 3-foot wire, so we're going to connect that to our slave axis. Just going to be on the right side of our machine if you're facing the back. So same thing, we're just going to plug this in. Alright, so let's move forward. Taking our 7-foot wire, same exact thing, and the 7-foot wire is going to connect to our x-axis. Alright, give those a tug. That looks good. So coming over here to our x-axis, just going to go ahead and connect that. Alright, so now for our last wire at 13 feet. This is going to go ahead and connect to our z-axis. Alright, let's go ahead and connect that to our Z. Alright, so now that we have all of our wire connectors connected, let's go ahead and move on to the next step. Alright, for this next step we're going to be assembling our LED light ring and our micro limit switches to our machine. So we need to gather these parts. We're going to have 3 of our micro limit switch kits, and as you can see I have 2 already assembled. Just want to give you guys an example of how this goes together. And I have 1 broken out, so you can see all the parts that are included in your kit. So we have spade connectors, drop-in T-nut, an 8mm screw, slot washer, 2 of our M3 self-tappers, 1 of our micro-limit switch plates, and a micro-limit switch. So in addition to that, we're going to need our wire, which we're going to have 2 conductor wire, 2 being at 13 foot, 1 being at 7 feet, and then our last wire, which is going to connect to our LED light ring, is going to be at 18 feet. In addition to that, we're going to have our LED light ring, as well as the 2 6mm screws that come with it. And as you can see, I've detached my router spindle, and these are the screws that mount to our double wide gantry plate. So let's go ahead and start off here with our LED light ring. Let's go ahead and flip our router spindle to the back end, and taking our LED light ring, we're going to go ahead and mount it into these 2 holes on the outer ends. Let's go ahead and take your 6mm screws. We're going to fasten those into place. Alright, from there we're going to go ahead and mount our router spindle back to our double wide gantry. So these 2 holes here are going to be threaded. That's where our router spindle is going to mount. Let's go ahead and take our 8mm screws. Just going to run them through my black angle corner connectors. Let's go ahead and mount these back to our plate. Alright, and once we have that done, just make sure that's nice and sturdy. That looks great. So we're going to go ahead and plug in our 2 conductor wire to our connector here on the LED light ring. Underneath the LED light ring, you're going to see indicators of positive and negative. So if you get confused on where to place which wire, you can always reference back to that. What I'm going to show you here, on the right side it's positive, on the left side it's negative. So we're going to go ahead and loosen these pins. And from there we're going to take our 18-foot wire here and we're going to connect red to our positive and black to our negative. Alright, perfect. Give that a tug. Make sure that those are in there tight. That looks great. We're going to take our additional wire and just throw it over to the back of the machine. Alright, now we're going to move on to our micro limit switches. So as you can see, these two are configured into a horizontal configuration. And I mean that by the way that the micro limit switch is placed on the plate. If it were to be vertical, it would be turned 90 degrees. So these two we want to assemble in a horizontal configuration. This last one we're going to go ahead and assemble in a vertical configuration. And the reason for doing so, I'll show you as we get into the step, but this is essentially going to set on top of the Z-axis. And to give us maximum travel, we're going to run the plate off to the side. Alright, so let's go ahead and configure this to our micro limit switch plate. And also on the micro limit switch, you'll see indications here for common, normally open, and normally closed. Make sure that these are facing you, that way you know which ones you're connecting to. We're going to be using our common and normally open configuration, so just make sure that those symbols are facing you. So we're going to mount this plate from the back end. As you can see, the holes align here. So let's go ahead and run our M3 self-tappers in here and tighten those down. So from there, we're going to go ahead and run our 8mm screw through the top face of the plate. On the back end, we're going to add our slot washer, making sure your flat portion is facing you, away from the plate. And then we're going to go ahead and thread on our drop-in T-nut. Alright, and that's a vertically configured micro limit switch. So now let's go ahead and move on to our wire. So for our wire, we're going to use our spade connectors in order to adapt them to our micro limit switches. So we have two sets of wire here at 13 feet and one at 7 foot. Let's go ahead and start with our 7-foot wire here, and that's going to run along our y-axis as our y-axis micro limit switch. So with these spade connectors, what I like to do is fold your wire to give it a little bulk. Then we're going to run that into our connector. Go ahead and grab your wire strippers here. We're going to use the clamping end to clamp down on this connector. Now when doing so, you want to go ahead and place your grip around the top and the bottom of the connector and then squeeze down tightly. From there you should get a great connection. Alright, so we're going to do the same thing for our negative. Alright, perfect. So that's one down. And let's go ahead and do the same thing for our others. So starting here with our Z-axis, we're going to go ahead and grab our vertically configured micro limit switch. So what we're going to go ahead and do with our vertically configured micro limit switch, so let's go ahead and connect our 13-foot wire, and we're going to focus on the 2 points I discussed earlier, the common and normally open. So with our wires, we're going to have both red and black. Black is going to go to our common, which stands for common ground. So let's go ahead and connect our black wire to our common. Alright, and then the red is going to go to our normally open. So from there, we're just going to go ahead and place our micro limit switch in our front track. So right here is where we're going to place our micro limit switch. So just like so. And what you can do is you can tilt these terminals slightly. I wouldn't put too much force on these, but you can bend them just so you can give yourself some more travel here on your Z-axis. But that is your Z-axis micro limit switch assembled. Now these micro limit switches are versatile, so you can configure this differently if you want. That's the beauty of our modular system. We're just giving you a good example of how to mount this and what will work for your system. Alright, so let's go ahead and move on to our next micro limit switch. So we're just going to take this excess wire and throw it over. And don't worry about the mess back there, guys. We're going to label all of our wires, so everything is going to be organized. So don't concern yourself with the mess right now. So let's go ahead and grab our additional 13-foot wire. And once again, we're going to go ahead and put our black to our common ground and red to the normally open. Alright, so once you have those configured onto your micro limit switch, this is going to be for our x-axis. So we're going to run this towards the left side of our machine if you're facing the front. So what I like to do is place this micro limit switch in this back channel of the C-beam. So giving myself plenty of travel here, I'm going to align my micro limit switch with my y-axis. So as you can see, where my pin is activated, I don't really need much more travel than that, because my work area is going to be based on where my router spindle is located. So this position looks good. So I'm going to go ahead and mount that into place. Alright, and now when our X carriage comes into play, it'll activate on this micro limit switch. So that's perfect. So we'll take our additional wire and run it to the back with the rest. Alright, moving on to our 7-foot wire here, which is going to be for our y-axis. Once again, we're going to go ahead and plug in black to our common, red to our normally open. Alright, perfect. So now on the right side of our machine, we're going to come over here to our top track of the C-beam, and we're going to go ahead and mount this micro limit switch into place. Alright, now when the y-axis plate comes into play, it's going to activate on this y-axis micro limit switch. So that's perfect. Alright, so let's go ahead and take our additional wire and we'll throw it to the back with the rest. Excellent, guys. So now we have our micro limit switches in place along with our LED light ring. This is looking really sharp, guys. Alright, so let's go ahead and move on to the next step. Alright, so moving forward to the next step, we're going to be labeling our wires. So in this step we're going to need our blue painter's tape and a permanent marker. And what I'm going to do is grab each wire from the point of origin and label it accordingly. So starting here with our LED light ring, which is located here on our z-axis, I'm going to go ahead and grab a piece of tape and I'm going to wrap this around the wire completely. The reason I'm not going to use a flag is because it would rip on the drag chain. It is easier to ride on, but this way is definitely more efficient. You don't have to worry about your labels coming off, which would definitely be problematic when getting to the Xpro controller. So I'm just going to wrap this all the way around. And I'm going to label this one LED. Alright, so that's one down. So next I'm going to go ahead and move to my Z-axis micro limit switch, which is located here on the top of the Z-axis. I'm going to label this one ZM for Z micro. So next we're going to go ahead and grab our Z-axis motor, which is located right here, and we're going to label this one Z, and that's just going to indicate that it's a motor. So next we're going to go ahead and grab our X micro limit switch, which is located here, and we're going to label this one XM. Next we're going to move to our A-axis motor, which is located here on the right side of the machine if we were to face the back. And we're just going to label this one A. And this is going to be our 4th axis, which runs in unison with our y-axis. Next we'll go ahead and grab our y-axis, which is located on the opposite side as the A, and we'll label this one Y. Next we'll go ahead and move to our y-axis micro limit switch, and we'll label that YM. Next is going to be our x-axis motor, which is located here, and we're just going to label this one X. Alright, perfect. So now we have all of our wires labeled. So we're ready to go ahead and move on to the next step. Alright, so in this next step we're going to be assembling our x-axis drag chain to our x-axis. So we're going to need to gather these parts. We're going to need a 20 by 20 at 1000 millimeters, our slot cover, which is also at 1000 millimeters, 3 of our single L brackets, 2 M3 T-nuts, 3 M5 T-nuts, 2 drop-in T-nuts, 2 slot washers, 2 6mm aluminum spacers, 3 M5 15mm screws, 2 of our M5 8mm screws, 2 M3 8mm screws. In addition to that, our drag chain, of course, which is at 1000mm for our x-axis. And also our tooling, we're going to have an M5, M3 ball driver, and we're also going to have our wire strippers, which we're going to use these to cut down our slot cover. So that's a good place to start. We're going to go ahead and grab our slot cover, and we're going to run it through our 20x20. So right here on the end, I'm just simply sliding this through. And here on the other end, you'll see that I have a decent amount of space here on my 20x20. So this is going to be doubled. So I'm taking into account for the right side. I'm also going to want space because our single L brackets are going to be mounting on top of this 20x20. So right here, this is about perfect. I'll go ahead and get a measurement for you guys. So here we're at about approximately 5.5 inches. So we want to take that off of our 1000mm slot cover. So what I've done is I've left the excess here off the 20x20, and I'm just going to cut that off. And this additional piece we will use later, so just hang on to that. Alright, now that our slot cover is in place here, we're going to slide it down, and we want about the same space on each end. So that looks good. So from there we're going to take one of our M3 T-nuts and slide it in the left side of the 20x20. So this is going to be mounting here on the left side of the machine if you were facing the back. And after that we're going to slide in one of our M5 T-nuts, just like so. So the M3 is going to be mounting of our drag chain. The M5 is going to be the mounting of our single L bracket. Now on the right side, we're simply just going to slide one of our M5 T-nuts in there. And then we'll put this 20x20 to the side. Alright, from there let's go ahead and grab our single L brackets. Starting with this one first, take notice to the hole spacing. The hole spacing that's closest to the edge here is going to be mounting to our C-beam on this bottom track. The hole spacing that's further is going to be mounting to our 20x20. So let's go ahead and take our 15mm screws with a 6mm aluminum spacer and our slot washer, and go ahead and thread on your drop-in T-nut. Alright, so once we have that configured, let's go ahead and mount this into our C-beam. So you want to make sure that the single L bracket is configured like so, and let's go ahead and do the same thing to our other. So once you have it configured, let's come over here to the right side, and let's mount that into place. So now let's go ahead and grab our 20x20, and we're going to mount that to our single L brackets. So taking our 8mm screws, let's go ahead and mount that into place. And same for the other side. Alright, perfect. Excellent. So now we have our 20x20 mounted to our C-beam. So now we have a cable tray, guys. That looks really good. Alright, so let's go ahead and configure our drag chain. So taking notice to our end caps here on our drag chain, they should be mirroring each other, and that's perfect because one is going to be laying in the track, the other is going to be mounting to our X carriage. So make sure that they do match this. Alright, so taking our M5 15mm screw, our single L bracket, and an M5 T-nut, we're going to mount this to our X carriage. So taking the spacing that's closest to the edge here, let's go ahead and run that through our X carriage right here at the center hole. And let's go ahead and tighten that down. Alright, perfect. So now what we're going to do is go ahead and run our wire through our drag chain. So we're just going to focus on these three wires. So our Z-axis motor, our Z-axis micro limit switch, and our LED light ring. So I'm going to find the ends of each one of these wires. And what I like to do with these wires is I just go ahead and tape the ends. That way the wires do not snag on the drag chain. So I just use painter's tape and just wrap these around the wires. It really helps with the assembly because we're going to be pushing this through the drag chain, so we don't want anything holding us up from forcing this through. So this works really well. Alright, just like so. Let's go ahead and grab the drag chain, making sure that we are facing the end that's going to be mounting to our X carriage. So this is going to be on our cable tray. This is going to be to our X carriage. So let's go ahead and run that through. Alright, once it comes out the other end, we're just going to pull that additional slack through. Alright, so once you have your wire pushed through the drag chain, what I like to do is leave some slack here. That way we don't have any issues when mounting our drag chain. So just leave a little slack there, and we're going to set our drag chain down. And let's go ahead and move on to our X-axis micro limit switch. This wire is going to run through our slot cover. So let's go ahead and find the end of the micro limit switch. And from there we're going to run this through our slot cover down here. Alright, you should see it come out the other end. Once you see the other end, let's go ahead and pull that slack through. Alright, once again you want to leave a little slack here, just so there's no tension put on your switch, and that looks great, guys. Alright, so let's go ahead and take the end of our micro limit switch, and we're going to run that through the bottom of our drag chain. So right here there's a space in the drag chain. We're just going to run this wire right through. That way this wire can stay with the rest of them when we run it through our Y-axis drag chain. Alright, so once you run it through the bottom here of the drag chain, you're going to pull the slack through, and we're going to mount it to the center hole of our drag chain. So right there. So we're going to mount that to our M3 T-nut. So let's go ahead and grab one of our M3 8mm screws, and let's tighten that down. Alright, once that's tight, we're going to work our way to the right side of the machine. And once again, we're going to mount through the center hole, this time from underneath. So what I like to do is just put this on the end of the ball driver and run it through the center hole. Grab your M3 T-nut, and we're going to lock that into place. Alright, that's perfect. So now our X-axis drag chain is assembled. That's looking really sharp, guys. Alright, so let's go ahead and move on to the next step. Alright, so we're moving to the next step here, and as you can see I've rotated my machine 90 degrees, and this way we can access our Y-axis. We're going to be assembling our drag chain on this step, as well as our slot cover for our micro limit switch. So if you haven't done so, go ahead and rotate your machine. In this step we're going to need our 500mm drag chain, our slot cover, which is going to come at 500mm. I have cut this down to 490mm. So this is a good place to start, guys. Just go ahead and measure that out. And the purpose of cutting that down is so we have room here in our slot to move the wire from underneath and out to our Xpro controller. So in addition to the slot cover, we're going to have 2 single L brackets, 2 M3 T-nuts, 2 M3 8mm screws, and a self-tapping screw. Our tooling, we're going to use our power drill and M3 ball driver. So to start off here, guys, we're going to go ahead and take off our end cap here on the furthest to the right position. So let's go ahead and take that off. And we're going to utilize this set screw for our single L bracket. And this end cap can go on the opposite end of the 20x20. That way you always have a secure cover. So let's go ahead and put this to the side. Alright, grabbing your single L bracket, we're going to use the spacing that's closest to the edge here. And let's mount that to our 20x60 underneath our machine. And make sure you keep your single L bracket as straight as possible. And if you need to readjust the position, you can use your ball driver and straighten it. Alright, that looks excellent. Alright, so moving forward here, let's make sure that our drag chain is configured properly. You should see that both of your ends are mirroring each other. So we're going to have one hanging from the bottom portion of our single L bracket that's going to go into our 20x20, and then our additional that's going to lay on top of this single L bracket. Alright, so that looks good. So let's go ahead and mount our additional single L bracket. So right here on the 20x20, we're going to use our additional self-tapping screw, and we're going to use the spacing that's closest to the edge. And let's go ahead and mount that to our 20x20. And once again, you just want to make sure that that's straight. That looks good. And this is really a perfect example of the modularity of the OpenBuilds system. As you can see, we've utilized our single L brackets in multiple positions in order to have this configuration. So I mean, simple solutions to simple problems. This is really cool. So any type of design that you have, rest assured the modular system is always there to help. Alright, so let's go ahead and take all of our wires, so everything except our Y-axis micro limit switch. we're going to run through our Y-axis drag chain. So the only addition besides these bundles is going to be our X-axis motor. So what I've done is I've taped all of those wires once again with just some painter's tape. You can use masking tape, anything just to keep those wires secure so they're not snagging on your drag chain. And we're going to run this through our drag chain. Once again, making sure that the top portion here, which is going to mount to our single L bracket, is the right position. So we're going to run our wires through this first. So once it comes out the other end, we're going to pull all that additional slack through. And the cool thing about this drag chain is it is modular as well. You can disconnect these links, reconnect them for growth or shortening of the drag chain. And these caps also come off. So it really helps with wire management, especially when you're trying to feed all these wires through the drag chain. Definitely want to utilize maybe some of that because it can be frustrating at times. But generally this works pretty well. Just be patient. Alright, once you have fed all of the wire through, we're just going to pull a little slack here. That way we can mount our Y-axis drag chain. So from here we're going to go ahead and lay down our drag chain, and we're going to go ahead and set this up for our configuration. So with the left hole, we're going to mount our back end of the drag chain. What I like to do is place the T-nut underneath. All you have to do is pull your machine off slightly. And I just thread on the M3 T-nut, and then I tighten it down with my ball driver here. Alright, that's perfect. So let's go ahead and push the machine back. Alright, and then same thing for the top portion, except we're going to be mounting from underneath. So let's use this left hole. So I'm just going to place this on my ball driver and run it through that hole. And let's go ahead and put on our T-nut. So now that this is in place, I'm just going to pull that additional slack out of my wires here. Alright, that looks excellent. So now we have our wires configured into our Y-axis drag chain. So the last step is going to be to grab our slot cover. And what we're going to do now is take our Y-axis micro limit switch, and we're going to run it through this top slot here. What I like to do is leave a little slack here to run behind the micro limit switch plate, and then from there we're going to go ahead and run our slot cover. Alright, and as you can see, we have plenty of room here to run our wire back and around our motor. So we're going to place this with our additional wires. Alright, and that is the assembly of our Y-axis drag chain. It's starting to shape up, guys. It's looking really good. So let's go ahead and move on to the next step. Alright, for this next step we're going to be assembling our Xpro controller. So go ahead and locate your controller and pull it out. What I've used is the diagram card on the back of the Xpro. So out of the package, I've just pulled this out just for a plate so I can assemble this Xpro without any debris getting on the actual controller. So one thing I will say is go ahead and rotate your machine to the back. We want to make sure we have access to all of our wires that are running from our Y-axis drag chain, and it's just going to help for the assembly. So going over a couple things here on the Xpro controller, we have our motor inputs, which are going to be for our Y-axis. Each one is labeled. Our X-axis, our A-axis, which is going to be the slave to the Y, and our Z-axis. So let's go ahead and get started here. So let's go ahead and grab one of our wires. Checking the label, we see that this one is Y. So we're going to go ahead and correspond that to our Y-axis. Now it's very important that we do these wires in this order that I'm about to mention. So for A1, A2, B2, B1, and we also have our limit switch here, we want to correspond this how we attached our motors. So if you check your motors, you'll see that we have red, green, blue, and yellow. So we're going to go in the same order to the Xpro. So we've got red, green, blue, and yellow, and we're going to work our way from left to right. That's the main portion that you're going to need to get correct in order to have your motors functioning correctly. So if the coil pairs differed, your wire order would definitely differ. So based on the colors and your coil pairs, that would all relate to your controller. Alright, so if you have the new style of motors with the male connectors attached to the motor, this is how you're going to wire up your controller. So this is all based on the coil pairs. So we have red, blue, green, and yellow. And that's going to follow on every single axis. So as you can see, there is no difference in the ordered pair on either one of my axes. So that's for a lead screw driven machine. Now with the belt drive, that will differ, and throughout that video I do show you the same exact picture here of the controller setup. So if you do have the new style of motors, make sure that you follow this, pause the video if you need to, but these are the coil pairs and how they're going to align to your controller board. You need to make sure that every single one corresponds. So if you were to look at the new style of motors, and if you were wiring your motor directly into your Xpro controller, you can see we have it aligned. So this is just based on the motor coil pairs aligning to your controller. The only thing that we're doing is we're adding that extension length, which is going to connect to our male connector here from the female. And all of those connections are going to relay to your controller. And it comes back to the simple concept of the motor coil pairs just aligning to the controller properly. That way when you configure this into the software, you have no problems. So just make sure you pay attention to this. And if you do have the lead extensions, which are what we hooked up to our motors here, those lead extensions coil pairs are going to be red, green, blue, and yellow, and those will be configured in this video. So I'll be showing you how to insert each wire into the pin and clamp it down. And the micro limit switches, of course, for this controller, this is all going to be the same. The only difference is the ordered pairs of your motor coils. So make sure that you pay attention to this, guys. I'll also add a link in the description for this diagram, both motor and controller. That way you guys do have a diagram that you can look at. But this is pretty simple, you just need to make sure to get it correct. Alright, so let's go ahead and continue. So let's go ahead and prep our wires. So I'm going to start here with red and green, and I'm going to loosen my terminals here on the Xpro. Alright, once you have those terminals loosened, you'll see here, this is where we're going to insert our wires. So on top there's a pin that clamps down on the wire, so we've just loosened that, so now we can insert our wires correctly. So starting with red and green, give those a tug, make sure that they're fully inserted. That looks great. And you don't want to over tighten these screws either. I would just say just to where they're snug on the wire. So you definitely don't want these coming loose, but you don't want to over tighten this system. It could cause problems for you in the future if you wanted to remove these wires, replace a motor, so on and so forth. So just be careful. So next we're going to do blue and yellow. Alright, just give those a tug, make sure that they're fully inserted. That looks great. So now we have our Y-axis motor into our Xpro. So now let's go ahead and grab our Y-axis micro limit switch. And make sure that you read the label correctly. This is our Y micro limit switch. So for our micro limit switch, these are going to correspond to our limit switch section. We're going to have our red wire, which is going to be positive. Then here the symbol stands for your ground, which is going to be our black wire. So left to right, red and black. Alright, give those a tug, make sure that they're in there. That looks good. So let's move on to our next motor. So here we have our X-axis. So we're just going to locate that on the Xpro. Here's our X. And same exact thing, guys, red, green, blue, and yellow. Alright, so first we're going to insert red and green. Alright, just give those a tug, make sure that they're inserted properly. That looks good. So let's go ahead and grab the X-axis micro limit switch. Alright, and same thing, and do red and black. Alright, give those a tug. That looks good. Alright, so we're going to go ahead and rotate our controller, giving us access to both our A and Z axis. And we're just going to loosen these pins. Alright, and let's go ahead and locate our A-axis motor. And same exact thing, guys, red, green, blue, and yellow. Alright, give those a tug. That looks good. Alright, so we're going to move on to our Z-axis. So let's go ahead and locate that motor. Alright, and once again, guys, red, green, blue, and yellow, and then red and black for our micro limit switch. So let's go ahead and get that done. Alright, and let's go ahead and insert the micro limit switch. Alright, and once again, guys, we're going to insert red and black. Alright, perfect. So now we have our controller board configured. That looks great, guys. Let's go ahead and move on to the next step. Alright, for this next step, we're going to be assembling our OpenBuilds open case. So as you can see in your kit, these are going to be all the parts that are included, besides our Xpro controller. So 2 of our M5 15mm screws, 2 drop-in T-nuts, 2 3mm aluminum spacers, 2 slot washers, 12 of our M3 20mm screws, 8 of our M3 T-nuts, 4 of our M3 hex standoffs, 4 of our M3 12mm screws, 4 precision shims, our open case times 2, as well as our 90mm brushless fan. Also in this step, we're just going to require an M3 ball driver, and let's go ahead and get started here. So first off, we're going to grab one of our plates for the open case, and we're going to go ahead and mount our controller to the case. So taking the Xpro, we're going to lay it on top of the case, and you'll see that the holes align with the holes matching in the case. So we're going to run 4 of our 12mm screws through each one of these holes. Alright, from there, I'm going to tilt it on its side, and I'm going to thread on my M3 T-nuts. Alright, and once you have this threaded on, from the front of the case, we're going to use our M3 ball driver and just snug these into place. Alright, perfect. So now that we have that in place, next we're going to use our 20mm screws on each one of our corners. And this is going to be for our hex standoffs. So from underneath the open case, we're going to run our 20mm screws right underneath these holes. Alright, perfect. And what I do is I just hand tighten these. That's all you really need, because this configuration is built rather strong just with hand tightening these hex standoffs. Alright, in addition to that, I like to run all of my cables out of the left side of the open case, and that way what I'm going to do is bundle all these wires together and zip tie them, and I'm actually going to run them into the bottom portion of the open case, and from there I can sandwich on my plate, and it's perfect for wire management. Another thing that you guys can do, because this is completely moddable, is just snip the wire. So if you have excess wire that you just don't want hanging around your machine, just snip it off, strip down your wires, and reapply them into your Xpro controller. And that's definitely another option. I like to keep the extra wire just in case I want to mount this differently, so we give you that extra wire for that purpose exactly. So from here, let's go ahead and assemble our fan to our other piece of the open case. So on the open case, you're going to see 4 holes here on the outer ends, so not where the Xpro mounted, but up above. That's where our screws are going to mount. So go ahead and run those through. So we have our 20mm screws that we're running through currently, and then we'll rest this on its back. And from here we're going to add our precision shims to each screw, and then we're going to go ahead and stack our fan. Now we want to make sure that the sticker is facing us, because this is where the air is going to be pulled through the fan. So make sure you stack it just like so. And then we're going to add our M3 T-nuts to each screw. Alright, now that we have our fan mounted, we're going to go ahead and move on to our 15mm screws that are going to be added to this portion of the open case. And this is for mounting of the case itself to our extrusion here on the back of the machine. So these 2 holes here next to our hex standoffs are going to be the holes that we're going to run these screws through. So go ahead and run those through now. And then from the back end we're going to add our 3mm aluminum spacers, a slot washer, making sure that the flat portion is facing towards the mounting area, and then a drop-in T-nut. We're just going to thread that onto the screw. Alright, we're going to do the same thing for our additional screw. Alright, perfect. So now that those are in place, so now that we have that complete, we're going to go ahead and carry these 4 20mm screws onto the next step. And the reason for doing so is I'm going to leave this open, that way you can see how I mount my fan, as well as my power wire that's going to provide power to the Xpro. So let's go ahead and move on to the next step, guys. Alright, moving forward here to the next step. On this step we're going to be assembling our power supply, as well as configuring our power wire to run to our Xpro. In addition to that, we're also going to be zip tying all our components and wires, just so we have an organized system. So in this step we're going to require our open case, our 4 20mm screws that we brought over from the previous step, our 2 slot covers, and these are the additions that we cut down, 15 zip ties, our power wire for our Xpro, and our power wire for our power supply. In addition to that, we're going to have our tooling, our M5, M3 ball driver, Phillips, and a flathead. Alright, so let's go ahead and get started here. First with our power supply. We're simply going to take our power wire here and configure that into our power supply. So here on the power supply we're going to have indicators here for ground, neutral, and line. Now the way that this is going to correspond is we're going to have green for ground, white for neutral, and black for line. Alright, so let's go ahead and grab our Phillips. And we're going to loosen these terminals here so they can accept the wire. Alright, from there, I'm just going to twist these wires together, make sure we get a solid connection. And then we're going to run these wires into these terminals. Alright, once the wires are inserted, I like to make sure that the insulation is fully into each terminal. I'm going to clamp these wires down. Alright, perfect. So now our power supply is configured. We're going to go ahead and run our power wire to our Xpro next. So right here on the power supply, you're going to see indications for output, our positive and negative. So 6 terminals in total, 3 negative, 3 positive. So taking our power wire, this is our 2 conductor wire here. Just going to go ahead and twist these wires. We're going to go ahead and use these 2 terminals. Alright, once those are inserted, we're going to take our other end and attach it to our Xpro. So using our flathead screwdriver, we're going to loosen the terminals here on the power for our Xpro. And here on the Xpro, you're going to see positive and your ground. So we're going to correspond that correctly. And once those wires are inserted, go ahead and tighten it down. Alright, give that a tug, make sure that they're inserted correctly. That looks great. Once again, you want to make sure that the insulation is fully inserted, and that's for all points around any type of electronics. Just make sure that those are fully inserted. Now let's go ahead and take a zip tie, and right here on the open case, you're going to see 2 slotted holes here. This is for the purpose of zip tying your power wire. So we're going to go ahead and run our zip tie through. Just make sure that's nice and tight. From there, we're just going to snip off the excess. Alright, perfect. And the reason for zip tying this is we do not want this power wire coming loose. So if there is any type of pulling motion, the zip tie is going to absorb some of that force. So it definitely helps with keeping the system completely secure. Alright, so that looks great, guys. So now from here, we're going to go ahead and bundle our additional lengths of wire. Unless you decided that you wanted to cut these down to where they fit in line with this unit, all you would have to do is snip the additional lengths off, strip it down, and run it to each point. But for us, we're just going to go ahead and bundle these wires together. I like to keep the excess just in case I want to configure this differently. So let's go ahead and bundle these wires together. So what I like to do is grab them from this point, and from there, I'll roll the excess into a bundle. Alright, once you have your wires bundled, we're going to go ahead and grab one of our zip ties, and we're going to go ahead and zip tie this bundle together. Alright, and we're going to do that in multiple points here just to make sure that this unit is tightened down. Alright, and then we're just going to snip off the excess here. And this bundled wire we're going to simply place into our open case. And what I like to do is align it towards the bottom of the controller. That way we have plenty of airflow to cool our controller. So it's very important, guys. You want airflow to this controller or it will malfunction. Alright, so before we put this case on, we're simply going to plug in our positive and negative here for our fan. So right here we have an input. You're going to see positive and negative. So red for positive, black for negative. Let's go ahead and plug that in. Alright, once that's inserted, we're going to place the top half of the case on top, and we're going to mount that into place. So take your 4 20mm screws. Let's go ahead and tighten this down. Alright, perfect. That's looking really sharp, guys. So we have our case enclosed. So now what we're going to do from here is go ahead and mount this to our V-slot. So I like to mount it right here on the left side of the machine. So right here you're going to see access holes to our screws. So let's go ahead and mount that down. So that's perfect, guys. So now we have our case mounted. We have our power supply configured. So what we're going to do now is go ahead and take our LED wire. We're going to go ahead and plug this into our power supply. You'll notice that you do have quite a bit of length here on your LED wire, and the purpose of that is so wherever your power supply goes, if you want to mount it up front or to the side or down on the floor, you have that option because your LED light ring is going to have that extension. So what we're going to do here for our LED light ring, similar to how we powered our Xpro, from the output of our power supply, we're going to run both positive and negative on these 2 terminals. So let's go ahead and loosen both of these. and then let's tighten them down. So now anytime that we want to power on our machine, our LED light ring is going to power on as well, which is really convenient. Alright, so we have that configured. So now we're going to go ahead and move on to organizing all of our wires, making sure everything is aesthetic, make sure everything is just going to be nice and tidy. So let's go ahead and grab one of our zip ties, coming over here to where the open case is located. Any excess that I have, I'm going to bundle together and zip tie as a unit. The only thing that I'm going to exclude is my LED light ring. I'm simply going to run that underneath my open case, and wherever my power supply goes, so will my LED wire. So now as I run to the back of my open case, I'm going to bundle these wires and zip tie them together. Alright, and once we have those bundled, I'm going to move on to my connector here. What I like to do is run a zip tie through each one of these connectors to make sure that they stay attached. And if there's any pulling motion on your machine, you don't have to worry about your connectors coming loose. So I simply run it through the wire, back around, and then tighten that down. And snip off the excess here. Alright, if you want to go a step further too, you can zip tie this to your 40mm aluminum spacer. All this is completely moddable and customizable, so it's kind of up to your preference of how you want to bundle this together and how you want to configure it. This is just a good example of how we're utilizing our zip ties. So if you want to configure this differently, by all means, configure it to your liking. Alright, and the reason I like to mount it to the actual spacer is so I don't have to worry about this lead dragging along the machine if I were to want to rotate it or anything like that. Alright, so that's looking really sharp, guys. So let's go ahead and move on to our x-axis. So once again, I'm going to go ahead and strap in my connector. And these wires actually look good. They're nice and uniform running into our y-axis drag chain. So I'm not going to zip tie those. The connector actually looks good too. It's tied in well to our drag chain. So let's go ahead and move on to our z-axis. So once again, we're going to go ahead and zip tie this connector. Alright, and for these additional wires, our LED light ring and our micro limit switch, we're going to use those additional slot covers to tie these into this front channel of the C-beam. So this piece here that we cut off for our 1000mm slot cover, I'm simply going to cut in half. That way I have two pieces here I can use. So keeping these together, I'm going to run a slot cover in the slot. And then our additional wires here, I'm going to go ahead and zip tie. And let's snip off that excess. Alright, so our additional slot cover that we cut in half, we're simply going to run towards the bottom part of our C-beam. And that's just to cover up the excess here for our LED light ring. Alright, now looks great, guys. So let's go ahead and move to our A-axis. So here on our A-axis, we're simply going to zip tie this connector. Alright, and in addition to that, we're going to take our additional piece of slot cover and we're going to tie in our wire to our 20x60 down here. Alright, we're going to pull that additional slack into the slot and we're going to zip tie our connector to our 40mm aluminum spacer. Alright, once we have that configured, we are all set to move on to the software section, guys. So let's go ahead and move on to the next step. Alright, on this next step, we're going to go ahead and connect our USB cable to our Xpro controller, and then we're going to attach it to our laptop. So taking the serial port here, we're going to connect it into the top right position of our Xpro. So go ahead and connect that. Once you have it connected into your Xpro, let's go ahead and move our USB cable to our laptop. And let's plug that into the USB port. Alright, once that's done, let's go ahead and move on to the software portion. Alright, so moving forward here to the software portion, we're going to go ahead and open up our browser. And from there, we're going to go ahead and type in openbuilds.com. And up at the top here, you're going to see tabs. And we're going to select the software tab. From there, you're going to have an option to download OpenBuilds Control Machine Driver. That's exactly what we want. So let's go ahead and download right now. Alright, and once it downloads the executable here, you're going to get a prompt that's going to say Windows protected your PC. We're going to select more info. We're going to run that anyway. Go through the prompts, I agree, next, and install. Alright, and then we're going to finish that up. And from there, you're going to see an option to start the machine driver. Alright, so once you're in there, we're going to go ahead and select our COM. So from the serial port of our Xpro controller, we're going to select the COM that it is using. So go ahead and connect. And from there, it's going to populate our Gerbil settings. So here on the top tab, we're going to select Gerbil settings. And here you're going to see our settings and values that we're going to go ahead and input into our controller. So now from here, to get these settings correct, we're going to go to the OpenBuilds forum. So we're going to go back to OpenBuilds. We're going to select OpenBuilds machines. And then we're going to go ahead and select our machine specifically. So we're looking for the Sphinx 1050. So here it is. Let's go ahead and select that machine. It's really cool. There's a lot of information, reviews, details, files and drawings, parts lists, discussions. The forum is a great place for resources. So definitely look into it if you haven't actually interacted on the forum. It's a great makerspace. Definitely for all builders. If you have any questions, definitely come here to the forum and you get immediate responses, which is really cool. So we're going to go on down the build page. And you're going to locate Gerbil settings. So we're going to click to expand, and it's going to give you all of your Gerbil settings for this machine specifically. So all of these values have been calculated, so it's for your convenience, and you can just take these values and copy them right over to your machine driver. So I'm going to go ahead and minimize this. That way I can copy these directly over. Alright, so here on our first key, so it's going to be indicated as 0. It's our step pulse time, microseconds. That's going to be set at 10, so that is correct. So now going on down to 1, we're going to set that to 255. 2 is our step pulse invert. That's at 0. So then at our step direction invert, we're going to invert the Z direction only. And this is really cool too. So instead of just knowing the value off the top of your head, you actually have options here. So if you want to invert your Y, you would select this. Same with the X, so on and so forth. We're only going to be inverting the Z. So that is correct. So we're going on down to 4, and we're going to enable. So we're just going on down these really quick, guys. We're going to go ahead and input all these values so you can get your machine settings correct. If you want to know additional information, it's provided on the forum for firmware as well as Gerbil information and what all these indications mean. So if you want more descriptions, there's definitely resources out there. We're just going to give you a rundown on how to set up your machine specifically. So on number 5, that is disabled. 6 is also disabled. 10 is going to be 1. 11.020. 12 is 0.002. 13 is disabled. 20 is disabled. 21 going to enable, and this is for our micro limit switches. So hard limits are enabled. Our homing cycle enable is also enabled. We do have micro limit switches hooked up. So here at homing direction invert, this is going to be set at 3. So the only axis that you're going to invert for our homing cycle is going to be C. That is correct. So 24, we're going to set that to 100 millimeters per minute. And then the homing search seek rate here at 25 is going to be 1,000. Now you can adjust these later on if you want. If this is too slow for you, you always have the option to come back and update that into your firmware. So here at 26, we're setting that to 250. 27 is at 3. 30, we have at 1,000. 31 is at 0. Laser is disabled. We're not using a laser. 100, so this is going to be steps per millimeter. We're using a lead screw driven machine. So we are setting this at 199.100, and that's going to be for all three of our axes. So you also have a calculator here, which is a really cool option on our software. So you can do the calculations here, and it'll give you your value, which is really, really nice. All right, going on down to 110, running our maximum rates at 2,500 millimeters per minute. So that's for all three axes. 120 is going to be set at 150, and that's going to be for all three of our axes. 130, and this is going to be our maximum travel in millimeters. So we have 833.500 for our x-axis. 131 is going to be 325, and that's for our y-axis. And our z-axis is going to be at 85. So now from there, we're going to go up to Save to Firmware, and you're going to select that, and it's going to save all of your settings here into your firmware. All right. So now from here, we're going to go into the Control tab, and we're going to jog our machine around. All right, so let's go ahead and test our machine out. We're going to go ahead and do some jogging. First thing we're going to do is go ahead and unlock our alarm. This is a safety feature for our software, which is really nice. Definitely protects the user. So we're going to go ahead and unlock the alarm. And from here, we're going to go ahead and test out our positives and our negatives. So let's make sure that our machine is functioning correctly. So a positive movement should move our machine back towards our open case for our Y. So we're going to go ahead and press the positive button here. You can see that my increments are set at 10 millimeters. So let's go ahead and jog that. Oh yeah, that works great. You can see here on our digital readouts, it's showing how many increments you've moved. This is a really nice feature. So if we move back, which would be a negative movement, it's going to go back towards the front of the machine. Perfect. So now let's test out our x-axis. So positive movement would be to the right, towards the x-axis motor. So as you can see, that's moving great. Negative movement, move it back to the starting position. All right, now we're going to bump this down to 1 millimeter increments for our z-axis. A negative movement is going to be going down into the material. Positive is going to be up away from the material. So we're going to go ahead and bump a negative movement. And as you can see, the negatives are working correctly on the z-axis. Same for the positive. Excellent. All right. So our machine is functioning correctly. All our values are correct. If there was any issues, you can always go back to the Gribble settings and reevaluate. Maybe you entered in something wrong and just double check that. But for us, we did everything correctly. Our control is working excellent. So now let's go ahead and do a home cycle. So here at the top of our machine driver, you're going to see tabs for Home All. This is going to be for our micro limit switches. So we have our micro limit switches set up for homing cycle. So we're going to select Home All. Now if we have any issues, you can either power down your machine or stop the job. It is immediate. So let's go ahead and Home All. It's going to start with the Z here first. And then it's going to move the X and the Y. And that worked great. All right. So let's go over a couple more features here in this awesome software. So on the troubleshooting tab, we have options here so you can see which micro limit switches are operating correctly. So if you were to touch one of your micro limit switches, you would see, so I'm going to touch the Y micro limit switch. You'll see it turn on as far as the status goes, which is really cool. So you can test all of your micro limit switches through the troubleshooting tab, which is really convenient. And you'll also see that this is set up for hard limits. So if you were to accidentally bump your machine in the wrong direction, it's gonna, if it touches a micro limit switch, it's gonna activate your alarm. So the machine's not gonna move once it activates that micro limit switch. So before you can move your machine again, you have to hit Unlock Alarm. Go back to the Control tab, and you'll be able to move your machine freely. So to show you that situation, I'm going to move my y-axis towards my micro limit switch. And once it touches the micro limit switch, oop, there it goes. Just tripped my alarm right there. So I can unlock this alarm, and I'm free to move again. So it's a nice safety feature here for you. And I really appreciate the thought put into the software, because that's definitely a nice feature for hard limits, especially for a machine of this size. So now I want to go over a couple more features here in the software. So you have options here to open your G-code. You also have tooling options, so you can set up your outputs on your Xpro for your motor section to turn on a tool. So for instance, like your router spindle. You also have coolant options here as well, which is really nice. And we've also got a jog widget here. So if you select that and you scan the barcode here, you'll be able to control your machine from your phone. It's awesome. Alright, so here we have G-code editor. So you can actually insert G-code and edit your G-code accordingly. You also have the 3D view, which is a really nice feature. So once you upload G-code, you can change the orientation of this and watch your machine work live. Really cool stuff here. Also, you can adjust your jog feed rate, which is really nice. You can adjust this live, depending on your settings, of course. If you have a max value of 2500, you're not going to go above that, but you can change your feed percentage rate as well as your tool percentage rate, which is really nice. Really love this software. It's very powerful and it's free, guys. So definitely something to consider, because we have our CAM G-code generator as well as our OpenBuilds machine driver that work together, and it's great software. We love using it, and for any type of builder, this is the way to go. So you also have simulations here. So before you run your G-code, you can simulate the tool paths. You can adjust the speed of the simulation. Really cool stuff here. Alright, so from here, guys, we're going to go ahead and run our Hello World. So let's go back into our browser, and going into OpenBuilds, we're going to go back to the tab that says Software. So go ahead and select Software, and here you're going to see options for your OpenBuilds CAM G-code generator. So this is an online platform, so we're going to browse to, and from here you're going to go ahead and set up your machine settings. So we're going to select Settings right here at the tab. Select Settings once again, and you're going to set up your controller. We're using the Spark Concepts Xpro, and our machine is the OpenBuilds Sphinx 1050. We are not using a laser, so when you select your tool, let's go to, you have options here, which is really cool as well. So you have your spindle option, as well as enable misting, cooling. Really cool stuff to add on this CAM software. So for us, we're doing an air cut, so we're not gonna select any tool. And from here, based on our machine, the OpenBuilds Sphinx 1050, all of our parameters are correct. So that's for our workspace and the CAM G-code generator. Everything looks good there. So now we're just going to save these settings, and we're going to go back to our workspace, and we're going to go ahead and open our Hello World example. Let's go ahead and select that. And from there, you'll see that it's calculating the tool paths, and it's going to generate that G-code for you. So as you can see here, it's generating the G-code, and it's going to show you all the tool paths. It's awesome. All right, so let's go back to our machine driver. So right here, you're going to see an option to transfer your G-code to the machine driver. So let's go ahead and select that. And it's going to pull up the 3D view here of your Hello World and all the toolpaths inside of your machine driver. So that's awesome. So we can simulate this right now. So as you can see, we're at 1 times here. So if I want to speed that up to 10 times, even 100 times, you're going to see it speed up. So as you can see, it's doing all the toolpaths, so it's showing exactly how your machine is going to be working, which is really convenient as well when you're setting up your 0 point. You want to make sure that it's in the vicinity of your mill or your tool that you're using. This is awesome. So we're just going to stop that simulation, and now we're going to go ahead and find our 0 point. So back here in the Control tab, we're going to select 1 millimeter increments here. Well, actually, first I'm going to home our machine. Let's go into home our machine to a home position, which is really easy to set up your 0 point from there. Basically, all you have to really do is lower your Z-axis. But essentially, you just want your router spindle the front left position of your machine. So I'm going to go ahead and bump my X-axis out slightly. And this is just precautionary as well. We're going to move the Y-axis as well. But it's precautionary because you don't want your machine to bang against the sides while it's running this G-code. So you want to make sure you find a good 0 point to start at, especially if you have material that you've already used and you're trying to find a different 0 point. you would want to set that point based on where the material is located. So let's go ahead and bring our z-axis down. We're going to bring that down slightly based on the movements of down and up from the tool path. So it's going to be delving down into the material, back out to change its orientation. So from here, this looks like a good 0 point. So I'm going to set 0 for X, Y, and Z, just like so. Everything zeroes out, it looks good. So from here, you have run job. We're going to select that. If you have any issues, once again, power down your machine or hit stop job. It is immediate. Definitely be safe, guys. All right, so let's go ahead and run this job. And here in the 3D viewer, we're watching our machine work. I'm going to change the orientation here. You can see how it's dipping down into the material. So if you had any type of wood or material you wanted to mill out, you could definitely do it with this G-code. This is awesome. Our machine's alive, guys. It's working great. This is really exciting. So thanks for tuning in, guys. Make sure to subscribe to the channel. We got new content coming out all the time. So you definitely want to keep up to date, and good luck on all your future builds.